I have something to admit. You may have been told that I'm in London, and I am usually London-based, but I'm actually speaking to you from a hotel room in Croatia, which is why my setup is a little strange right now. I'm currently balancing the t-shirt that I'm going to show you later on a suitcase. So please forgive me if the sound drops out a little or if the Wi-Fi goes a bit strange. I'm doing the best that I can. But a little bit about me. I am a developer advocate at Ably, which means that I get to make all kinds of fun projects to show off what Ably can do. Now, we provide a reliable and pleasant to use pub/sub infrastructure that allows developers like you to build apps that use real-time data. And just sort of to show you the kind of things that you might be able to make with real-time data. So this is an example of an app that I made that tracks all of the buses that are moving in Connecticut in the US in real time. You can see that at the URL down at the bottom there. Or this, which was a peer-to-peer game that I made using pub/sub. It's a multiplayer game where you get to draw silly pictures and then you have to guess what somebody drew, and then the next person has to draw from your guess. I highly recommend playing it with your team. It's very, very silly, and you can see it at that URL there. And one of my favorite things to make is wearable technology, specifically things with a lot of lights on that can connect to the internet, because I really like to be sparkly. And I started making wearable tech projects a couple of years ago. My first one was a very bright lit up tweet controlled wedding dress. And when I started making wearables, I didn't really have a clue about what I was doing. I made quite a few very silly mistakes. These were mistakes around choices of what hardware to use, how to stick it together, how to interact with it. And so my hope for this talk is to give you a little direction if you're looking to get into a hardware project, to help you over that initial hardware is scary hurdle, because I'm assuming that most of us are software developers. So for this project, I wanted to make something that we could all interact with together, because I don't know about you, but social distancing has made me really miss hanging out with other humans. I miss having my friends and my colleagues around me. And so I wanted to make something that we could all interact with together, and it would be like having you here in this room with me. So I thought, what if I make a wearable that lets everybody change the color of what I'm wearing in real time? I'd be able to see the changes as you're making them, kind of like a multiplayer live version of Microsoft Paint, but wearable. So in order to realize this dream, we're going to need a few things. Firstly, we're going to need an array of lights, which are going to change color. We'll need a microprocessor to control these lights, and we'll need an app where the users can set the color of the lights. And then we'll need a method of sending messages from the app to the microprocessor. So let's start with the array of lights. It's going to be a 16 by 16 grid of LEDs. And the LEDs that we'll be using in this project are called addressable RGB LEDs. The addressable part of that means that we can target each LED individually. Each LED in the strip has a number, and we can use that number to turn just that one LED on. And RGB means that we can set it to basically any color that you can think of, using a similar color value to that which you've probably already seen in CSS. So your RGB brackets 3 numbers, that's exactly the same thing that we're sending to these lights. And if you're looking to buy these lights for your own project, the product name is NeoPixels. And they come in these ribbon strips, which makes working on them nice and easy because we don't have to individually solder each LED. When I originally made the dress that I showed in the previous photo, that had 200 LEDs in it. And I bought individual LEDs, which meant that I had to solder 200 LEDs together. And not only that, each one has 6 solder points on the back. So that's 200 times 6, which is a lot of soldering. I don't recommend. I highly recommend getting the ones that are already soldered together on a strip, or you can buy them in a ribbon where they have wires between each LED. It also makes them a lot more robust when they're on a ribbon, because every solder point introduces a point of weakness, a point where if you're wearing it and it bends, it could potentially snap, and then you've lost your circuit. The fact that they're on this ribbon just makes them that little bit more robust, that little bit safer for a wearable. And these strips are also great because they have very clear labeling, so you can see very easily where you have to connect up the 5 volts, which is the power, the D, which is the data, and the minus, which is our ground. So it's much less easy to make the mistake that I made when making the dress, where I stuck all of the LEDs into the dress and then realized that they were all in different directions and that soldering them together was going to be a complete and utter nightmare. So to keep these strips safe in a wearable, the first thing that I did was I took 2 pieces of fabric and I sewed them together in lines to make pockets to insert each strip into. And I have visualized that here, and I will show you my sewing. I am a very terrible sewer, so it's not very neat, but hopefully the visualization will show you what you should do. So once I'd sewed that, I inserted each strip into each pocket, and then I needed to solder the strips together to form one solid circuit throughout the entire LED array. So you can buy a soldering iron and solder online for about £30, which is about 30 euros these days. And I used single core copper wire to connect them up. And the reason why I use this when I'm soldering is that if you buy the stuff that has many different wires in it, they have a tendency to fray, and then soldering them onto something is much more difficult. You buy the single core, there's just one thing that you attach. Much easier to solder, a little bit less robust. It has a tendency to disconnect, which I will talk about later. But that's what I used. I also recommend getting a heat-proof silicone mat to put on your desk to keep it safe when you're soldering, and incidentally, these double up as excellent baking sheets for cookies if you are that way inclined. And there are lots of tutorial videos online on how to learn to solder, so I won't go into that here. Suffice to say that it isn't too scary, and once you've had a few goes and a few practices at soldering, you'll get the hang of it very quickly. So once both ends are soldered up, we finally have a finished flexible LED array. And the finished array looks like this. So you can see it's quite flexible, it bends, it's pretty bright, all of the things that we want for a wearable. So we have a flexible LED array. Now we need a way to control the colors that we're going to send to that array. And for this, we're going to use a microprocessor, which is useful here because they can do enough calculations to control the lights, but they're also nice and small, so they're easily hidden inside a wearable. And I opted for this microprocessor, which is called the Adafruit Feather Hussar. And I like this one because it's very, very small. It's just 5 centimeters by 2 centimeters. And it comes with Wi-Fi on the board, which means that unlike some other boards, you don't have to be soldering on extra peripherals to get Wi-Fi connectivity. Come straight on the board. Less soldering is better, in my opinion. It's also not too expensive. It's about £20 to buy. And it weighs very little. I think it weighs 5 grams. It's low power, which means that it can take power from a USB battery, and all of us already have phone charging batteries around, so you'll be able to have a battery in your pocket to power your t-shirt. And it runs C and C++ code out of the box, and you can write code for it using the Arduino IDE, which is free software that comes with a whole load of really useful libraries and example code. Which is brilliant if you're a beginner and you need to get up and running quickly. You can have a look. They've got code to run NeoPixels. They've got code to use any kind of board that you can imagine, libraries to connect you to the internet, like absolutely everything you need. When writing this project, I needed to write very little code. A lot of it was already there. So the code for the Hussar looks a little bit like this. So what you can see here in this code is the first thing that I've done is that I've included the library for the NeoPixels. And then I've defined the pin that I'm going to be sending the data out on. So this is the information that tells which LED to light up. And I've defined it as pin number 4. So I'm going to connect my data line on my LED array to pin number 4 on the board. I've then told it how many lights I've connected. 16 by 16 is 256. And I've told it what kind of lights they are. So in this case, they're Neo RGB lights. Now this is something that I got tripped up on when I was making the dress. I bought some very cheap knockoff NeoPixels online, and they came in 2 different sets. And one was a Neo RGB and one was a Neo RGBW, which I didn't realize takes an extra value. So when we're sending our RG and B value, it also took a W value, which is the white value, which tells it how bright to be, which meant that chaining up these lights together just didn't work. They weren't able to turn to the right color. So when you buy your lights, you really want to make sure that you double check whether you've got RGB or RGBW. They both work exactly the same, it's just that one you need to send an extra value to. So the next thing we're doing in this code is initializing the strip. So strip.begin gets the pixels ready to receive data and sets all of them to an off state. Then we're going to loop through each LED and use the setPixelColor function, which takes a number, which is the position of the LED along the strip, and a color to set it to. So in this case, we're using 255, 255, 255, which you may recognize to be white. So what we're doing here is looping through every single LED in the array and setting it to white. Just to show you the pins on the board that we'll be using, this is the board. The data is going to pin number 4. I'm going to be powering it through USB. You can see the USB connection at the bottom of the board there. So I shall be using USB to connect to power, and then ground goes to ground. So now that we have a display and a way of controlling it, we need a way to tell the controller what colors to set. And I'm a web developer, so I opted to build a web app. And you can check out the code for the web app here at the link shown. And don't worry, I will share the slides out at the end of the talk so you can peruse the code at your leisure. I am going to talk through some of it now as well. So the app that I built looks like this. It has some buttons at the top where the user can pick a color. And it has an SVG of squares that represents the pixels in each array. And each square in the SVG has an ID with its number in the array. So 0, 1, 2, 3, 4, 5, 6, all the way to 16, 17, 18, 19, 20, carrying on. And once the user has picked a color from the top and then chosen a square in the array, the app will update the fill of that square to match the selected color. But we also want it to light up the correct LED on the t-shirt. So we're going to need some sort of messaging service in order to connect the app with the t-shirt. And we do that using a real-time messaging service to send a message that contains the color and the pixel number from the app to the t-shirt. So of course, I'm going to be using Ably to do this, which allows me to create a channel and to publish messages to that channel from the app as they happen. And the microcontroller on the t-shirt can also subscribe to this channel and get those messages nigh on instantly. Every time a pixel is changed, a message is published on the channel, and all of the subscribers to that channel will receive it, which means that anyone else who is using the app will also get those messages. And you can have a go of the app at this URL right here. So let's have a look at some of the code for the app. I will just leave that URL up there for a little while for those of you that would like to connect to it. So the app is built with Node and Express. And on the front end, as I mentioned, I used Ably's messaging platform to set me up with the channel. I use the JavaScript SDK because I'm a web developer and JavaScript is my language of choice. And then I used the methods for creating a channel and publishing and subscribing to messages on this channel. So if we have a look at the code here, first thing we're doing is making a new instance of the Ably real-time library. Then we are creating a channel called T-shirt and connecting to it. And as I mentioned earlier, the cool thing about this is that anybody using the app will also receive these messages. So as you can see, I'm assuming this isn't all one person drawing, you're all seeing each other's messages at the same time. And we're using the Ably SDK comes with a create token request method, which allows us to authenticate with the Ably SDK without having to put our API key straight into our front end. It keeps the API key nice and safe. As an aside, all of the code for this is on GitHub, and I will share a link at the end, so don't worry if you'd like to have a look at this later. It's all open source. You can take it and make it your own. So now that we've established a connection to a channel, we need to publish a message to that channel when somebody clicks on a square. So what I did is I added a listener for a click on any of the pixel squares, and when clicked, it will get the number of the square, and it will change the fill of that square to be the color that was selected. If you're not familiar with SVG, fill is exactly the same as background color. It'll then publish both the square number and the color value which was selected to our T-shirt channel. So an example of one of the messages that might be sent would look like this, where I click on square number 1 and I set it to purple. It has a hex value of AAOOFF, which is purple. So we have 001 sent and the color. But we want the app to also display the pixels which are clicked by other people, which means that we need to subscribe to the channel as well as publishing to it. So what I'm doing here is subscribing to the channel, and then I've got a few different methods. The first one being, well, the important one being sync single pixel, which splits up the square number and the color value and applies the supplied color to the relevant square. And then reset display, which is also important, which I'm running every so often just to clear the board. But what it also means is I can have a control at my end just to make sure that nobody can draw anything not safe for work on a 16 by 16 square while I'm giving a live talk. So now that our app can update its own and other people's displays, we also need a way for it to get the data from the app to the board itself. Now, you're probably all familiar with HTTP. This is the protocol that browsers use to request web pages. And HTTP is a protocol, which means it's the way that two things talk to each other. And HTTP is great. It powers websites and APIs, and it's built to be descriptive and flexible, and it can be used for IoT connections, but it's not lightweight, and it's not incredibly fast. And another problem with HTTP is that it's pull only. So the device has to constantly connect and then check, are there any updates? How about now? How about now? And that is not only quite slow, it's definitely not real time. It takes a lot of data and therefore a lot of power. On a low power IoT device like this one here, that can be quite a problem. We don't have very much memory, we don't have very much power, we don't have very much bandwidth. So we need protocols that are designed to be small and fast. And that's where MQTT comes in, which is the Message Queuing Telemetry Transport Protocol. And it's a connectivity protocol which is designed to be extremely lightweight. Connecting to a server takes only about 80 bytes, and the device stays connected the entire time. Data is published when it's pushed from the device, and the device can subscribe to data in the exact same way that we did with our JavaScript. And because the size of the data being sent over MQTT is small, messages can be sent quickly, making the hardware incredibly responsive, making it feasible to update lights in real time. So in order to use MQTT, we're going to need an MQTT broker. And a broker is a server that the devices connect to using the MQTT protocol in order to listen for messages. and it keeps track of all of the clients that are connected and the topics that they're subscribed to and forwards the correct messages to the subscribers. And in this case, I'm using the Ably MQTT broker, which is mqtt.ably.io. And the awesome thing about this is that any messages that I publish or subscribe with the JavaScript SDK are also sent out over MQTT by default. It requires no extra setup by me. It just works. And no extra setup in my books is a winner. So let's talk about how we connect the microcontroller to the MQTT broker. So using the Adafruit Feather Huzzah with the Arduino IDE is really nice and straightforward. You can install the IDE from the Arduino website, and they have a really clear walkthrough on how to get it set up on the Adafruit website. There's a link there, which again you can get when I share the slides later. The IDE, as I mentioned, also comes with a whole load of example code and all the libraries that we will need for this project. So in order to connect the board to Wi-Fi, we're going to need the Wi-Fi client library. And then to use MQTT, we're going to need the mqtt.h library. And then what I'm doing here is I'm creating a config object, which is going to make setting up these connections a bit simpler. So in the config, I have my Wi-Fi credentials, so my SSID and my password. And then I have the MQTT broker host name, the port, and the authentication that I need for that. And the username and the password are two parts of my API key. It's split up with a dot, which makes it very clear which part is which. And then that scary looking blob of hex code there is the fingerprint or thumbprint, depending on which browser you're looking at, of the SSL certificate for the Ably broker. So it's the SSL cert on mqtt.ably.io, and we need this for the Wi-Fi client secure library to verify the SSL certificate when it tries to open a connection. If you don't provide this fingerprint, the connection will fail. But once you've got the fingerprint, you put it in your code, you put it in the config, you never look at it again. So the final thing that we have then here is the name of the channel that the board is going to connect to, which is T-shirt. And similar to what we did for the web app, we need the Huzzah to connect to the Ably MQTT server and then to subscribe to the channel. So first we create new instances of the Wi-Fi client secure and the MQTT client. And then once we're connected to Wi-Fi, the secure client lets MQTT use SSL to connect to the channel using the credentials that we set in the config. And then when a message is received, we can process it with onMessage. So let's say we received the example message that I showed earlier. So this one here. What we will do when we receive that message is we first need to split out the square number and the color so that we can set the correct color on the correct LED. And so what we do is we split it at the hash character into two separate strings. We then convert the hex value of the color into RGB, and then we send the pixel number and the RGB value to the lights to update. And the eagle-eyed amongst you might have spotted a slight problem in the way that I wired the lights up. So let's take another look at that array of squares from the web app. I give each of the squares a number to represent the number of the pixel in my LED array, like this. So when we read, usually we go from left to right. This is how arrays are enumerated. This isn't how I soldered my lights together. I wanted to keep my wires nice and neat, so I soldered these little jumps at each end. Not only that, I connected the cable up at the wrong end of the first strip. So if I was to represent these LEDs on our pixels, my array now looks more like this. The first row is reading backwards, the second row is reading forwards, the third row backwards, and so on and so forth. because I wanted to keep my wires nice and neat. So I soldered the end so we didn't have trailing wires. Now I have affectionately named this method of enumeration snake mode, because we're snaking through the array, which means that I essentially have to reverse every other line of the array. So on the board, I made a method that checks whether the position needs to be reversed. So here we use the X and Y values, so X being across and Y being up and down, to work out where the pixels should actually go. So to calculate the row the pixel is on, we divide the pixel number by 16 and then modulo 2 to work out whether or not we're on an odd or even row. And then I can work out how many pixels came in the rows before that pixel. If it's an odd row, I minus the X position from 15 to get its reversed position and add that to the chunk of pixels that came before it. And then I know which pixel value I need to send. I'm told that this is actually how some pixel arrays work, due to the exact same reasons that I made it this way. It makes your wiring much neater. I don't have trailing wires starting me at the beginning of each row. So now we have an RGB array. We have a microcontroller to tell the lights what color. We have an app which we can set colors on, and we have a way of sending messages from the app to the board. So now it is time for the prayer to the demo gods, who clearly have already honored us today. And I'm going to make this full screen, hopefully. In fact, I'll leave the QR code up there on the URL for you, just in case you're not there yet. And let's stop sharing my screen. And hopefully we go full screen now. And I'll just turn this a little closer and I'll give you some time to play around with the app. It is an absolute miracle that this is working, because as I mentioned earlier, I flew to Croatia a couple of days ago to give this talk in real life. I gave it on a stage. They're running an open air conference. And when I took it out of the box after it was on the plane, one of the wires at the end had snapped. I was mentioning earlier that every single solder point that you make, you're potentially adding a vulnerability in, and that solder point had broken. So I had a panicked run around Split in Croatia trying to find some sort of glue that I could glue the contact back on with, just as a stopgap measure, because I thought it unlikely that I would find a soldering iron at such short notice. So it's incredibly fragile at the moment, and I'm so glad that it is working. And I'm so glad you're all playing with it. Thank you. And so let me start sharing again. I have one last screen. That is just to say thank you so much for listening to my talk. This is the link to the project on GitHub. If you follow me at that Twitter address, I will tweet out the link to the slides so that you can get all the links and have a look at the code yourself. I put all of my speaker notes in my slides, so you will be able to read everything that I've just said as well. And thank you so much for listening.
Wow, so we've already had a question come in, but before we touch on the questions, we'll give everybody else a chance to post some more. I hear a little birdie has told me that you're part of another event later this week. Would you like to tell us a little bit more about that?
I would love to tell you about that. So the event is called Inclusive Design, and it's a 24-hour long conference on inclusive design. So be it web design, be it product design, anything that needs accessibility, which of course we all know is everything. And it's on Thursday. The website is inclusivedesign24.org. I highly recommend you check it out. It's free. It's running all day. The talks will also be up on YouTube. So if you don't want to sit through a 24-hour conference, which honestly none of us do, you can check out the talks later. But I will be hosting for a few hours on Thursday afternoon, UK time.
Nice. I've got my ticket. I am really looking forward to it. The talks sound absolutely amazing. I'm ready to absorb everything.
Yeah.
So let's start on these questions. Have you got any plans of creating an Iron Woman t-shirt?
Oh yeah, I should totally do that. I kind of love that idea. I mean, it would be super doable because you don't need very many LEDs. I mean, the problem with this t-shirt here, I mean, you can't probably see my face is very pink because there's so many LEDs, they get quite warm, and I'm powering it with this battery here, which is quite a hefty battery, which also gets quite warm. And the reason why I'm not wearing the t-shirt at the moment is because it's 32 degrees in Croatia and nobody wants to see rivers of sweat running down my face as I'm speaking.
No, I for one am glad. But Croatia, 32 degrees, that sounds very nice. And I saw a photograph of you on the stage at the event in Croatia, and wow.
I know, right? How often do you get to speak at an event with the sea behind you?
Yeah, it's nice. At least you weren't in the sea. I mean, that would have made you a little bit cooler, I guess.
Well, I might have gone for a swim this morning.
Ah, lucky.
Yeah, I'm trying not to rub it in too much, but also jealous.
Ever so slightly. I've been stuck in this 30-degree studio lit office for the last 4 days. So we have had another question come in. Have you done anything for COVID-19 with your IoT stuff? So they've asked if you would be keen to make a modular COVID-19 defense mask.
So that is my next project. I found out recently that you can buy very cheap RGB LED arrays with very tiny LEDs in them. And so my plan is to make a mask which has an LED array on it, which has already been done. You can buy them online, they're very beautiful. But my plan is to put a microphone in and use some Azure machine learning to do speech recognition, speech to text, and then you can have subtitles of what you're saying on your mask, which I have a slight, well, my reason for doing this is that my mother is very hard of hearing and relies on lip reading quite a lot, and is finding everybody wearing masks very difficult. So we could maybe remove that difficulty by having subtitling of what you're saying while you're wearing a mask.
That would be really useful. He'd be father-in-law feels exactly the same. He's been very excluded throughout all of this, and he's a very, very social person. It sounds like it's very similar to what you're talking about there. Would you use the same board for that, or would you go completely different, do you think?
I don't know. I haven't quite decided yet. I might go a slightly different board because you can get even smaller boards because it's going to have to be teeny tiny to fit in a mask, but also maybe a board that's slightly more powerful, and then we could maybe cut out the middleman that is the web app and have the board talk directly to Azure. We'll see.
Fingers crossed that it works. So somebody did have a question about a board. Why did you choose that specific board that you used for your IoT t-shirt? Was it purely because the internet and Wi-Fi was built into it, or something else?
So the fully truthful reason why I chose this board was because when I started out, I had no idea what I was doing. So I sent out a tweet and said, like, help, if someone, so I originally chose this board for my wedding dress with the LEDs in, and I tweeted saying something along the lines of, if somebody was planning on putting 200 LEDs in the dress, what board would you recommend, Twitter? And a bunch of really lovely hardware hacking people suggested this board to me. And so I tried it out and I loved it. It works really well for this project. I don't know if you can see it. It's that size. So it is really tiny. And the fact that it comes with Wi-Fi on the board makes such a huge difference. Also, I love Adafruit. They really have got a whole load of example code up there for you. So when I first started working on that dress, I had it connected up to just a string of LEDs that I bought and had it showing colors on those LEDs within, I don't know, 10 minutes of connecting it all up. Like, it was a really nice, quick start. And you can get much cheaper off-brand boards, which, if you're slightly more comfortable with what you're doing, might be the better option. I know you can get a similar board for about £5. And of course, there's a million billion other options as well.
Yes, yeah, there are a hell of a lot of options, and lots of clones, in brackets clones, because it is all open source, that stuff, isn't it? And that leads on nicely into another question, actually. You said about Adafruit being a brilliant resource for learners. Somebody has asked if you can recommend any resources and if you think it would be safe for them to leave their kids to do it alone.
So if you're teaching kids, I can highly recommend the BBC Micro. And that has all kinds of things that you can just clip onto it, which means no soldering. So if you want to get your kids into it, the BBC Micro is great. It also comes with a visual programming language. So instead of having to write programming, you can just clip bits of logic together. And they have a whole load of resources online for programming for the BBC Micro. If you want your kids to solder on their own, I'm going to leave that decision to you. Get that cookie sheet is all I'm saying.
I love how you've sidestepped any responsibility there for soldering mishaps.
Yeah, I mean, I've burnt my fingers many a time picking up the soldering iron when I thought it was cold and it wasn't. So, I mean, when you're soldering, the temperature that I usually have my soldering iron at is about 390 degrees. So definitely not children safe.
No. And on that note, I think we're going to have to leave it there, unfortunately, because we've got another session just about to start. But it segues me nicely. Somebody asked if they could see a picture of the dress you made, and I believe that is the pinned post on your Twitter profile. So maybe we can tell people where they can find you online.
So if you go to @thisisjoefrank, FRANK, you can find me on Twitter, and there is a picture of the dress there. I think Sophie has also very kindly posted my Medium post about the dress into the chat here as well.
Perfect. So on that note, Jo, it was absolutely amazing to see your talk, and good luck with your journey back from Croatia and the conference on Thursday.
Thank you so much. Lovely to see you, Tony.
Nice to see you too. Everyone will be heading over to the 2 panel sessions momentarily. You can find the links to them somewhere in Remo and also on the CityJS website. So we'll see you there shortly. And Jo, thank you once again.
Thanks.